And we're back.
Another episode of The Road to Code.
Oh, yeah.
Episode 9.
Oh, man, this is episode 9? It is, huh? That's crazy. 9 episodes. Who would have thunk? Who would have thunk it?
Who would have thunk it?
Cool. All right. So the meat and potatoes of this episode is going to be table relationships, SQL joins, and stored procedures.
All right.
Everything that you have on the screen right now is useless unless you can reuse it, if you know what I mean. So imagine you have to, well, you know what? We'll get into that in a moment. Let's talk about table relationships. In databases, especially, so SQL Server is a type of database called RDBMS, Relational Database Management System. And so what it means is that you can have two tables, and these two tables can be related to each other. Okay. So we created this diagram through the Ssms diagramming tool. And this is a canvas that allows you to put your tables onto this canvas, and it gives you a visual. And you can create tables here. You can modify your tables. You can, if you right click on the address header and you show all columns, go to the table view.
Oh,
yeah, and standard, sorry. Do the standard view. And so this gives you all columns. So now do me a favor, let's put table and address on top of each other. Yeah, give a little bit of space in between them. Yeah, that's perfect. That's good. And let's go ahead and save this. And so when you're working with this diagramming tool, you want to make sure to save. Every time you make any type of little change you make, it doesn't even have to be a significant change. It could be any little change. You just want to save it, because every time you change something, there is a script being generated in the back end. And if you do too many changes, eventually that script is not going to be able to complete, because there's going to be something that conflicts with another piece of code that happened earlier, and it's not going to be able to finish it, and you're going to end up losing your work in this canvas diagram. So whenever you make a small change, just save it, and you know it'll save you some time in the future. But what we want to do is we want to relate these two tables. So we learned about the notion of a primary key, right? The primary key is what makes that row unique. So you can have ID and name, and the name could be Jonathan, 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 Jonathan for every single row. But what makes every Jonathan unique is a new ID. So 1, 2, 3, 4 is what makes that row unique. Okay. And we talked about, this is called the first level of normalization for databases. Okay. Is that every single row has to be unique. Okay. And we did the same thing with address. But one of the things that we also did is that we put a person ID in there. And so what that person ID represents is that address belongs to that person. So the ID of the record from the people table goes into that person ID column of the address table to say this address belongs to this user or to this person in the people table. So now you're creating a relationship, right? But there's nothing keeping you at the moment, there's nothing keeping you from entering a person ID for a record that doesn't even exist. And in order to keep your data integrity, we want to make sure that we enforce that rule. We say, hey, whenever you insert a record, and more specifically, whenever you insert an ID into the person column of the address table, it has to be a person ID from the people table. And we're going to do a couple things, right? So as we do something, I'm going to have you generate some scripts so that you can see the code that's being generated. What you're going to do, Jonathan, is you're going to grab the key from the people table and you're going to drag it and you're going to drop it right under the key of the address table. Right there to point to the person ID. Exactly. So you'll see here, let's read what this dialog says first, because it's full of information. The first thing is indicating is that you need to give this relationship, you have to give it a name. You just can't have a relationship for the sake of having a relationship. It has to have a name, okay? And the standard is there's a prefix of FK for foreign key. In other words, this is a primary key that belongs to a foreign table, a table that is not the address table, okay? And then the foreign key is coming from the address table and it's going or traveling towards the people, okay? So the foreign key belongs to the address table and it's coming from the people table. Does that make sense?
Yeah.
So that's kind of the naming convention. And SQL Server just automatically plugs that in for you. And you'll notice that it's on the, below that, on the left, it says, what is the table that has the primary key? And you'll see that it says the people table and the column is the person ID. And then it says, what is the foreign key table? The foreign key table happens to be the address table and it's the person ID column. And in reality, it's not so much that it's person ID from the primary table, it's the person ID column from the address table. So if the name of the column was ID in the people table, on the left, it would say ID instead of person ID. Does that make sense?
Yeah. It's just what we set the name as for the column.
Correct. Let's go ahead and hit OK. And you'll notice that it says, you see the line, right? There's a key and there's an infinity sign, which means that one record in the people table can have many records in the address table. In other words, a person can have more than one address. So you can have a work address, you can have a home address, you can have a school address, you can have a relative's address, you can have many addresses. It's an infinite number of addresses for any one person, but there can only be one person with many addresses. You can't have one address with many people. It doesn't, the relationship doesn't work that way. It's one person, many addresses. And that's kind of like where you get the key and where you get the infinity sign. Okay. So let's go over to the table designer menu and let's generate the script and let's see what code this made or what code it wants to execute. So go ahead and copy this code and put it in a query window. Open up a new query window. Up at top, new query. Yeah. And paste it in here. So the real code here, you can go ahead and delete 1 through 17. Oh, wait. Yeah, you can delete 1 through 17. And then you can delete 11 through 4. Well, look at you. You already know what to delete. You're like an expert now. So let's read this code. It says alter table DBO address. So we're actually altering the table DBO address. The people table, we're not altering. All we're doing is referencing the people table, but there's no alterations on the people table. The alteration is at the address table, and it's saying add a constraint. The reason a foreign key is a constraint is because the constraint won't allow you to insert a record unless the person ID is existing in the people table.
Okay.
If it's an ID that doesn't exist, it won't let you insert the record into the address table. Okay. So the name of the constraint is FK, foreign key, from the address to the people. And the type of constraint is a foreign key constraint. And the foreign key is with the person ID. So this is the person ID at the address table. And it references the people table, and the column in the people table it references is person ID. So this is where, if the column was named ID, it would say ID in there, not person ID. So this is the column in the people table. On update and on delete, you can go ahead and get rid of that. You don't need that. This is actually like a default behavior already. So this is the code that would execute in order to make what you just did in diagram happen.
Okay.
Okay. So you can save this and call it, making a relationship. And let's go ahead and save this diagram. And this will go ahead and execute that script. So now we have a relationship. So let's go ahead and edit the address table. On the left-hand side, and edit the top 200 rows. And let's go ahead and enter a person ID of 99.
Just on another one?
Yep.
Okay.
And go ahead and line 1, just say 123 some street. The city is anywhere, California. 90022. And go ahead and press enter.
So it says .NET SQL client data provider. The error message is the insert statement conflicted with the foreign key constraint. FK address people. The conflict occurred in database address book table dbo.people column person ID.
So as long as you know the name of the foreign key, you know what that foreign key is enforcing. So this is the clue that tells you, it's like, oh, that's right, 99 doesn't exist. But if you enter number, go ahead and hit OK. Replace that 99 with a 3 and press enter.
Whoops. How do I delete it?
Oh, you can just hit escape.
Okay.
Yeah, there you go. You're good. So it lets you put the third one in there because person ID number 3 exists in the person table. So you see how this works?
Yeah.
So this is relationships. And you could do that. You can do that in several levels. And we'll leave it at this for now. And we'll get into more complex relationships as we're working on other projects that we'll talk about in a little bit.
All right.
Let's go back to a new query. And let's go ahead and select some records. But we want to select records in such a way that we get the people records and the address records together, right? So we want to get person ID 1, 2, and 3. And we want to relate that to the respective address for each one of those. And we want to pull that data. You understand what I'm saying? So if we were to do 2 select statements, right? We would do select star from people. And then in a new line, you would do select star from address.
And execute both of them?
Execute both of them, yeah. We can see that record with address ID 5 is related to person ID 1. Address ID 6 is related to person ID 2, so on and so forth, right? But we want both of these records to show up side by side. And so the way that we would do that is we would say, go ahead and delete line number 2. there's a standard that we're going to follow. So put from people on a second line. And then after people, you're going to start another line, but you're going to indent.
Okay.
And you're going to say join address on people dot person ID. I think when it comes up, you should be able to press tab. Yeah, go back and retype it again.
Okay.
Equals address dot person ID. So if you just type in ADD, you should be able to tab. Oh, there you go. And let's go ahead and execute this.
The whole thing?
Yeah, just press execute.
Okay. Oh, cool. They're right next to each other.
Exactly. So the database knew, based on the relationship and based on your SQL statement, how to put these records together. So it said, okay, you want me to select everything, which is a star, right? You want me to select everything from the people table, and then you want me to join the address table. And the way that these two tables are related are based on the person ID columns of each table. We don't really need that second person ID, right?
Mm-hmm.
So how do we get rid of that?
I'm going to assume that we have to stay in the tab, and then we'll delete.
I wish it was that easy, Jonathan.
Ah.
We actually, instead of putting a star, we have to put every field that we want.
Okay.
So get rid of the star, and you're going to type in person ID, comma, full name, comma, birth date. We just need the address ID.
Oh.
But we don't need that second one, so don't select that second person ID.
And then just the address ID, and that's it?
Address ID, comma, line 1, comma, city, comma, state, comma, zip code. No, hang on. See how you have that squiggly mark under person ID? Hover over that and see what it's doing.
Ambiguous column.
So what does ambiguous mean?
So I'm guessing it thinks it doesn't know what to choose from the address or the person.
Exactly.
ID.
So now we have to go and fully qualify these columns if we have duplicates. So we would actually have to go and say select person dot person ID.
Person dot person ID. Or is it people?
People dot person ID. Yeah, sorry. I was testing you. You pass. You can go get a job now. and this works, so you can go ahead and execute it.
Cool. Yeah.
But people.person ID and over on line 3, people.person ID equals address. That's so verbose. You know what I mean by verbose?
Yeah, it's a lot of words.
It's a lot of words, right? So what SQL allows us to do, it actually allows us to put aliases on those tables. So from people space lowercase p on line 2.
Mm-hmm.
So space p, and p happens to be the alias name. And then you can do join address space a, and the a happens to be the alias for the address table.
On the same line?
No, on address, join
Oh,
address,
join
space
address
A.
space A. So I could delete this.
No, leave all that.
Oh.
But now people and address is no longer recognized. So you have to go and replace people with P, address with A.
Oh, just the people.
Correct. And then up on top, people that gets replaced with people, P. And that allows you to go and determine where each one of these fields is coming from, right? So you could do P dot full name, P dot birth date, A dot address ID, A dot line. So you would, now you can easily qualify them and make it explicit for all those. And if we execute this, see, go ahead and execute. But now as you look at that query, you can easily say like, oh, what's A? You go down to the from statement and you see like, okay, A is the address. And it's short, it's concise, you know, and it's being used within that SQL statement. And now, you know, it's, you can work with it, especially when you have a lot of tables. I mean, here we only have 2 tables, but there's going to be cases where you're going to have up to 5, 6, 7 tables that are you're joining. And you need 1 or 2 columns of each one of the tables. Having those aliases makes it really easy to write those queries. So that it makes a big difference as the queries grow. So there's one other thing. There's a format that is going to be followed, and it doesn't have to be within your queries. When you write your queries here, you can do this. You can be sloppy, you know, it doesn't really matter. But when you're writing them, and we're about to get into stored procedures, okay? When you're writing them, what you're going to want to do is you're going to want to keep a format. And that format is going to be, it's called a swim line. So there's going to be like this little line in between the SQL commands and the fields that you're relating. So if you put a return on after P dot person ID, put P dot full line in a new line, P dot full name, sorry, in a new line.
Okay.
And then tab, and then space a few times so that it lines up, so you line up the P's. Okay, and then do the same thing with birth date, address, line 1. Go ahead and put those on new lines as well. Okay, so you see how on the left side, you have select, from, and join. Those are the SQL commands, right? And then on the right side, you have the name of the fields and the name of the tables that you're working with.
Okay.
So that makes a swim line right down the center.
Oh, wow. Yeah.
And it becomes easier to read. It's easier on the eyes, okay? This is a very old school style guide. I like it, 1, because I'm old school. 2 is because it's very aesthetic. You know, it's like it's pleasing to the eyes. It's easy to see what are the SQL commands and what are the names of the tables and fields that you're working with. Does that make sense?
Yeah.
And so the other thing is that every single command that you're using has to be fully capitalized. So highlight select, and then control, what is it? Control Shift U. But this is a style guide that as we're writing our stored procedures, and we're going to get into stored procedures in a moment, this makes it very pleasing to the eye, and it's very easy to work with. I mean, it's SQL doesn't care what the format is. This is more for the human. Okay, that makes sense?
Yeah.
So go ahead and save this. This is, you can call it joins. So let's start a new query. So couple empty lines. Oh yeah, that's cool right there. Yeah. And let's add 2 more records to the person table.
Okay.
Oh man, you're gonna do it by hand? Go for it. Do it.
What?
Do
Oh,
it.
okay.
Do it. Go.
No, no, I won't.
No, it's good practice.
Okay.
It's good practice. Go for it.
Okay. Okay. Insert. We're gonna insert people, right?
Yeah.
Who are we adding? Minnie. How do you spell Minnie Mouse?
I think it's MNNIE. Double N
Minnie. Oh,
IE. Yeah. I want to say she was born 1972, and probably like July 3rd.
okay.
All right. This is actually good. We just need this one. Go back to your join query and let's execute this again. Because the instructions that you've given it is the fact that you're
It doesn't have an
joining.
entry address, huh?
It doesn't, Mini doesn't have an address. Now, if you want to include people without an address, you have to put a keyword on that join. And that join keyword would be outer join. Or you can do, there's a concept called left join, right join, and outer joins. Okay, so let's go ahead and let's start with left join. So instead of just join, you're going to type in left join. 2 words. All right, and let's execute this.
There we go.
So you'll notice that your results came up with null address information from Mini, right? You didn't provide the nulls. SQL Server is giving you the nulls. It says, hey, look, we're missing this information, but you've told me to do a left join. Now, let's go ahead and put line 10 at the end of line 9. And this left and right join is going to make a lot more sense to you in a moment. Okay. So people, the people table, people P, is on the left side of address within your statement. So when you're joining, you're saying, give me a left join. In other words, give me a join where all the records on the left are included, regardless whether they have a record on the right.
Okay.
Now we can do the other way around. We can put address first instead of people, and the relationship would still work. But now we would have to say right join because address is now, address is now on the left side. And in reality, people has more records than the address. So now you got to do a right join, saying, give me everything from the address, but right join the people. In other words, include all the records on the right of the table on the right, which happens to be the person table. So that left and right is in relation to where that table name appears on this statement.
Got it. Yeah.
Does that make sense?
Mm-hmm.
And so that's where you get the left and the right. By default, you get an inner join. In other words, you're going to match 1 for 1 on the table. If you have an extra one on one of the tables, it gets excluded. It doesn't get included. But if you say, give me a left or a right join, it says, okay, here you go. Here's both. And here you have this one dangling record without any records on the other side. And it's just, you have that. And that's the case that we have with Minnie Mouse. So these right here, okay, you see how you have all these squiggly lines? This is something to point out. These statements are for the significant database. if you look at your upper left hand, you'll see that you're currently in the context of the address book.
Mm-hmm.
To the left of the execute.
Oh.
Up above, yep.
Okay, right here.
So you need to select the significant database. So whenever you see this and you're like, wait a second, this worked before, why is it all squiggly? Look at the context that you're in, or look at the database that you're currently referencing. So each one of these windows can be referencing a different database, all right? These statements are useless if you can't reuse them. We want to be able to insert, but we want to be able to insert different values every time, right? And you want to be able to select for some filter, but you want to be able to select on a different filter every time. And you don't want to hard code it. You want to be able to use variables. The same thing with updates, same thing with deletes, right? And so the way you do that is you put this into stored procedures. Now, the tool that they give you to build the stored procedure sucks. So you're going to have to learn how to do the syntax on this one. We don't have much of a choice. So the first thing we want to do is we want to go ahead and copy the insert statement.
Oh.
Go ahead and copy that. And then open up a new query window. And this is just syntax that you're going to have to memorize. There's no real secret behind it. It's not like, let me go create a table and I'll use the designer and then I'll just generate the code. You know, that's like the easy way to do it. Stored procedures, just, you know, you're just going to have to memorize it. So the way that you want to do stored procedures is the syntax goes like this. It's create or alter, 3 different words. Proc, P-R-O-C. And then space, and then the name of the procedure. And the naming convention is the table name, underscore, and the action that you're performing. So in this case, it's going to be in the significant, it'll be the birth dates table, right? So it'll be birth dates. Mm-hmm. Underscore insert. And then the keyword that you'll use here is as, A-S. And then press enter. And then from this point is going to be the body of the method or the body of the stored procedure. And the body of the stored procedure, you can just put begin and end, 2 different lines. So in between begin and end is where you want to paste your insert command. And then your insert is going to be indented. And then you'll want to leave a blank line between begin and end. All right. And then you want to use the swimline format. Now, what we want to do is these values, they need to be dynamic. In other words, you need to be able to call the stored procedure and send these values in so that they're easily replaceable and it's all programmatic based on variables. So in between the create and the as, you're going to create a new line. And in here, you're going to specify your parameters. So go ahead and tab. And the name of the parameters, I normally do the same name as the fields, but I put an @ sign in front of them. So it'd be @ full name.
Okay. Put a comma for the rest of them.
Yeah, but you also need to specify, you know how you specify for when you create tables, the type? So you need to put like integer, varchar, all that stuff. So they need to match according to your structure. So you need to expand birthdays and expand your tables, your fields, your columns, sorry, yeah. So that you can see what are the types and you need to match that exact type. You don't need the created app because that happens automatically on an insert.
All right.
But you are going to need, so full name is going to be full name is going to be nvarchar what, 50?
Oh, 50. No.
You don't even have to put not null, just the nvarchar 50 equals. Just a space. You don't need the comma.
These are dates. And this one is a. Oh.
You can move the.
Now,
you can move
because the date of death could be a null value, not always supplied, you can easily put at DOD date equals null at the top. So the parameter itself, you can default it to a value of null.
So now we need to execute this. Well, it said it completed successfully. So, but what did it do, right? So if you look down in your, go ahead and collapse your address book, and then go down to programmability and expand programmability, and then expand store procedures. Look at the name and look at the name of your store procedure in your code. So if you expand the parameters, so those are the parameters that it's expecting, right? So one of the things that we could do is we can actually put some test code in here so that if this store procedure ever stops working, you can test it. And you can do it. We'll do it on a separate window. So go ahead and open up a new query. And you're going to go ahead and type in exact, EXEC space, and then you're going to give it the name of that store procedure.
So birthdates underscore insert. Underscore insert. Somebody else. Yeah, let's do Adam Osborne. And he's birthday 1939, 0306. He's still alive? Oh, 2003, 0318. And then his is the Osborne Computers. That's his notoriety. Oh, you removed his birth date. Oh, damn it. I thought it was a copy. It was his death date, though. 1939, 39, March 6th, 0306. Uh-oh. 0306. There we go. All right. So we just need 1, 2, 3, 4. 1, 2, 3, 4. Let's go ahead and execute this.
We're telling it create or alter this store procedure, and we give it a store procedure name, right?
Mhm.
Everything's got to have a name. And then, no, wait, go back.
Oh.
Yeah, we're going through the store procedure. And then we're including some parameters. We're specifying their type. And so these are the parameters that are expected. And then the stored procedure is specified as, and then you have your beginning and ending, right? And you say, here's the actual statement that needs to be included. So you're using your regular insert, but the only thing that's different is that you're using the parameters to replace the values in your statement. So now this is reusable because we can call it from anywhere, and all we got to do is pass in those 4 values, and it'll always insert, always insert. All right. We have the insert. Now we have to go and create the select all. So this would be like select star from a table. Okay. So you got your select all and you got your select by ID. So that's part of your read in the CRUD, right? Mm-hmm. And now let's go back to the store procedure.
Mm-hmm. Over here?
No, the tab with the store procedure. Yeah. So now we need an update. Now, what's left?
Delete.
Delete. I'm going to let you go through the delete because you have the statement, you have the store procedures.
Yep.
Let's see your work in action.
All right. So let me save this one first.
Yes, save as. Which one is your delete statement?
Right here.
Okay. So how does that compare to the other one that you got? Go ahead and minimize this window down to the size of the code.
Oh. The size of the code.
All right. So you see your delete statement at the bottom, that little window? And how does that compare to your delete statement inside your store procedure? What do you have that doesn't belong in there?
Delete. We have people and then person ID. Missing something here.
So in your delete, in the body of the statement,
Birth dates.
you have delete birth dates, which basically means delete from a table, right?
Mhm.
And if you look at the one from the address, it says delete from people, which is the name of the table, where the person ID equals 4. So what is it that you have in your store procedure that doesn't belong in there?
Oh, updated. Needs to get out of here.
And what else?
And that's it, right? Or nor ID or ID. No,
So
ID needs to be.
the set is used for the update only.
Oh, so we just need to get rid of the whole thing.
Exactly. There you go. And so look at the store procedure again. And how many parameters do you need?
Just one.
Okay. And what parameter is it that you need?
Just the ID.
So would it make sense to delete the rest of them? Which ones are your parameters? Highlight your parameters for me.
My parameters.
Yeah.
Oh, all these, huh? So I shouldn't delete all of them. Just the set.
No. You don't need that set. That set is for the updates only.
Okay.
So you don't need a set in a delete.
I need to add all of them on here, huh?
No. All you need. So your delete statement is complete. You're done with that. So the body of the store procedure is perfect just the way it is. What's wrong with your parameters? Your parameters are the ones that.
Oh, okay. So I don't need all of these then.
Exactly.
Just the ID.
Go. Yeah.
All right.
So you see, whatever you're going to use in your parameters, you use them in the body of the parameter of the store procedure. Whatever you don't use, you get rid of it, because at that point you're causing confusion and you're including more than what you should really include at that point. Does that make sense?
Got it. Yeah.
So, okay, so let's do a file save as. Let's go ahead and do a file save as on this. And this is your delete, right?
There it is.
So you got your CRUD, all right? You have your insert, which is your create. You have your selects. You have your select all and select by ID, which is your read. Then you have your update, and you have your delete. So that makes up your whole CRUD at that point.
There we go.
There is another mini challenge that we're going to do, and we're actually going to do one. I want to do one during the week. But before we get into that, all right, we got a little announcement to make.
Yes.
So I registered a domain called significant.info, and we're going to create a website. We're going to expand on this table here, and we're going to see how much we can do with this one little table. So for one, it's going to be open source. Once we're done, if people want to contribute, they're more than welcome to. They can have the code, play around with it, learn from it, whatever the case is, right? If you find a bug, let us know. We'll fix it. You fix it. Give us the code. We'll put it in. It's all good, right? So that's One. Two is we're going to host this on Azure. We're not going to host it on GitHub. We're going to host it on Azure. So we know Microsoft owns Azure, and Microsoft also owns GitHub. So it's no different whether you do it on GitHub or you do it on Azure. We're also gonna put up some automated features that come with Azure for free. So we're gonna put continuous integration and continuous delivery. So we're gonna set that up. We're gonna set some videos up and show how we actually do that. So we're gonna walk Jonathan through making all that. And we're gonna set up our database. So Jonathan's gonna have to create SQL scripts in order to be able to deploy the database. So you can go ahead and do all the fancy work within the editors and the designers, but you got to generate scripts in order to execute, because you're not going to be able to open up the designer on an Azure database. It's not possible. And ultimately, when we create this website, it's all going to be hosted on Azure. So we know that Azure, there is a cost to it, but I actually have a subscription that we can use, and we get I think it's either $50 or $200. I forget what it is, for free. And you might be able to open one up. We'll check it out. We'll see if we can open up one up with you and see if they give you any monthly credit to be able to play around with it. And if we could, we're going to go ahead and deploy this. We're going to leave it open for people to add stuff to it. And so we're going to see how the performance is. We'll write some code that will check performance and all that stuff. And then what we'll do is we'll also track the performance of the application with Azure. Azure comes with some tools that allows us to be able to do that. But yeah, we're going to do all this stuff with this one significant database on the significant.info website. And essentially, we're just going to track significant dates. And we'll figure out a way that we can continue adding. We're going to track birthdays for now. Eventually, we'll track, in tech and history. Maybe we'll add, significant something, I don't know, but we'll just go ahead and build on this concept. And we want to continuously deploy and continuously integrate in the whole thing. There's a challenge, but before we go into the challenge, I want to go ahead and end the meat and potatoes of this segment. So I think this one came out to be a quite a lecture, and I think there was a lot of information. There was a lot of meat and potatoes in this one.
Yeah.
And so I want to go ahead and close the meat and potatoes section off with this. And then we're going to be talking about the challenge next. But until the next episode, we'll see you guys.
See you later on the road to code.
That's right.